8.5 was a big section. We learned several things. We learned how to use the disk method. Go ahead and write down. We learned the disk method, which was pretty much adding circles on top of each other to create some kind of figure, whether it be a wine glass looking thing or anything else. Then we did the washer method, which is the same thing as the disk method, except you had a hole in it. So you could be you're pretty much adding washers on top of each other of different sizes. So I know my drawings are not that great, but the first one had like an integral with a pi, and you had to pretty much have a radius squared. And then if the thickness is happening vertically, then it would be dx, and if it was happening horizontally, it'd be dy. And if it's dx, r is in terms of x, and y, if it was dy, I will be in terms of y. Now for the washer method, same thing, except we have two. So we have a big radius squared minus a little radius squared. So you have to find expressions for both, and that's also in dx or dy. Now what we're going to do in this video is we're going to pretty much add any type of slices. It could be just circles, which we already done. It could be triangles. So in this particular video, it's going to be triangles, an isosceles triangle, and we're also going to be doing squares as well. We're going to be adding slices of squares on top of each other in order to make some kind of figure. Alright, so let's get started. Alrighty, so let's look at this one. Let R be the region enclosed by this graph and the horizontal line y equals 4, and the region blah blah. Region R is the base of a solid. For this solid, each cross-section is perpendicular to the x-axis. X-axis is an isosceles right triangle with a leg in R. Find the one with the figure. Okay. Alrighty. In this case, you pretty much end up having all these triangles. It says it's perpendicular, so I'm guessing this is what they look like. One triangle, and then two triangles, and three triangles, blah blah. So let's do this. So the basic area for a triangle is 1/2 base times height. So finding each individual, maybe I shouldn't use a highlighter. By the way, this has really nothing to do with washer method. So, I'm sorry for that. Oh, right triangle. Isosceles right triangle. So boom. So this should be the same as this, and then we have this right there. So because it has to be right. Alrighty. So 1/2 base times height. Base and height should be the same because isosceles. And then, yeah. So the area would be that, and you add them all together by doing integration. You're gonna end up creating this figure, which looks weird. You know? Yeah, it's kind of. It's just a bunch of triangles added together to create this. And I want to emphasize, this has nothing to do with the washing method. We're just kind of doing this. It's in here for some reason, so we're just going to go ahead and finish it. As part of an AP question, that's the thing. Alright, so we have this being the same, and this right here would be, this is y equals 4. We have to subtract whatever this side is, so y equals 4 minus f, because this is going to be f. Here's the thing. Let me use different colors. Why do I have blue twice? This right here is 4, right? But we don't want 4. We want this. So what we got to do is we got to remove this. So this entire red piece is 4, but we only want what's in black. So we're gonna have to subtract what's in green. So that's why we have 4, but just the red stripe. This is 4, and in order to remove, let's go ahead and use blue now. This part, we're gonna subtract f of x. So that's what this is going to be, and because it's isosceles triangle, this is going to be the same thing. So I'm 4 minus f of x, 4 minus f of x, and we have our little slice of a triangle. 1/2 base times side is the area of this triangle, and we have only one of them, which is why it's dA, not the entire. You keep adding all of them together. You add them all together, you're going to end up getting your volume. So your little dV is going to be this, but you're gonna have your dx, because if you add some kind of thickness to it, this is just an area, but the moment you introduce a little thickness, then it becomes a volume. So here's your integration from 0 to 2.3, because that's when they intersect apparently. From 0 to 2.3, 1/2 times that squared dx. And then you do it, use a calculator again. I'm not going to spend too much time on that. And then it continues right here. Yeah, I'm not going to worry about that at all. I need to teach you guys about Washer method. This is feeling like I'm getting off topic with what I'm trying to teach in this video. So this would be like an AP question they might ask you. This was a very hard paragraph to understand. You know what I mean? Oops. This was a very hard paragraph to really understand. You have to kind of look at keywords. Perpendicular to the x-axis is what kind of told me it's the triangles are happening this way. And then the fact that isosceles triangle kind of told me that the base and the height were going to be the same thing, which is going to be whatever this length is. So it is not an easy problem. So if you followed me, good job. Good job. All right, so let's move on. We're not going to worry about C. Hopefully the next one is the Washer method. Alrighty, the last problem actually isn't the Washer method one. It's kind of similar as the other one. You have to figure out the dA. So you figure out an area, then you need to do some thickness to make a dV, and then you do an integration. So I really have mixed feelings about doing this. So I will go ahead and do it, and I want you guys to watch it, but not take notes on it. And then I'm going to take a picture of another Washer method problem, and then we're going to have you take notes on those. How about that? So just prepare to, for this video it's going to be a little longer. It's fine. Just skip ahead. If you, no, I don't want you skipping ahead. Watch this. Just grab some popcorn or something. Alrighty, so let's read this. So let f equals this and g equals that. R is the region bounded by the graph of f and g. Okay, that makes sense. That just tells you that this is going to be the bottom part of it. We don't know what kind of figures we're going to create, because we could be creating some triangles up in here. We could be creating some squares. It looks like it's going to be squares. We could be creating all kinds of stuff. And as we go to like the narrow ends, like the square would get smaller, you know what I mean? So that's pretty much what we have to worry about happening. So this is our R. This is just a base. It doesn't tell us about what the figure is going to look like yet. As shown in figure above, which is figure below. I don't know why they call above below these days. Below above. The region R is the base of a solid. For this solid, each cross section is a perpendicular to the x-axis. Okay, so it's got perpendicular. So it's going to be rising, you know, it's going to be like that. It's not going to be like this, because that would seem parallel. Like the square isn't going to be like this, like facing. It's going to be, I'm really bad at drawing stuff, but let me see if I can do this. What that means is, if I'm actually going to add some, this is what the solid is going to look like. Once I add like some, and then, actually, this is what each square is going to look like. Alrighty, because it's perpendicular. Alright, that was actually a really good job. That was pretty good. I was doubting myself. Alrighty, let's continue. We have, so, what was I? the square, right? Do not evaluate the integral expression that gives the volume of the. Oh, nice! You don't have to, right? Like do it. That's ideal. So the average square is going to be s squared, and s is going to be this distance right here. So it's going to be whatever this is. So we have to pretty much do the top function minus the bottom function, and yeah, just have to do that. So the top function seems to be, what is this? How do I know which one's the top function? Alrighty, this is clearly the cosine function. Clearly. I know what cosine looks like. So the top function is cosine, so it's going to be cosine minus, yeah, there we go. It's going to be cosine minus the other function, because the bottom function seems like the other one. So that's just the area. When you introduce some thickness to it by adding a dx to it, so without dx, dA, there's no dx, see? You attach a dx to that, dv, because you're taking an area, you're multiplying by thickness. Thickness, this is dx right there. This is dx. You're adding some thickness to it. And then we integrate it from 0 to 2, because that's where they intersect. All right, so boom, and this is fine for the AP test because it says write but do not evaluate. Nice. So that's all we have to do.